This conference will now be recorded.
So welcome to part 4 of this training session. Today we're going to cover two topics. The first is the script language and the comparison of script language to ExpressionList. And the second thing we're going to try to cover is the DRAM block. This is something that's being used pretty extensively. This will probably be the last session we'll be doing after this. If there's any additional sessions required, they can be answered on Q&A. Now, the script block is something that's probably going to be used very, very extensively in almost every part of your design. It can be for like doing an arbitration algorithm, or it can be for creating a fully custom traffic generator. It can be used for even writing some logic or even an algorithm itself, or a scheduler arbitration, or even data processing for plotting purposes, things like that. So a variety of uses. So which means that the script language has been built so that you can do these things. It's not a generic language that you can use it like a Python or a C, C++. It's been built very specific for modeling. And another thing that has been done to it is it's been integrated with our Regex language. So the way the code is written, again, there is some uniqueness here in the code. The way the code is written is that you have the lines of code, you have some initialization functions. So this is something you might do in a .h file in C or C++. So before the words label colon begin, you do these. So what happens is during initialization of your simulator time, these things are executed. Now, when it comes time to the fire, what happens is all the data coming in on any number of input ports. So this block can have multiple input, multiple outputs. Big difference with ExpressionList, it's an ORing of the input port. So when anything comes in on any port, it's accepted. Unlike the ExpressionList block where it requires all the data available on all the ports before it can start executing. Big difference. So when it comes in on any of the ports, it first is put into an input queue over here. There's no priority in the queue. It's ordered in the order of arrival, except of course the virtual connections where it comes in from another script or comes in from an in block, from an out block or things like that. Those are the only ones they get higher priority, so they always go jump up the queue. But anything coming in on the ports will always order in the order of arrival. Okay. Now, this, as I mentioned, this code is executed in initialization, and then you have the actual code starting up here. Now, let me go into an actual model so you can get a feel for. So in this particular case, the block here is located in the behavior directory, a script. You drag and drop the block. Now, with the new version of the tool, you double click on it, it shows you the actual code. If I right click on it and I say customize, configure, it'll show you all the parameters and any additional parameters you want to add. So it has that capability. Now, the default block, when I bring that over, has one input and one output port. The key aspect of the block is the name parameter. Every instance of a script or smart controller block in the entire model must have unique names. So we're using hierarchical of classes. It's a good idea to have a name associated with the hierarchy or with the class, so that you can concatenate names or strings over here to create the name of this particular block. But it's very important that every block has a completely unique name. Now, you can add as many ports as you want. Similar to the expression list, you go customize ports, and then you can add all the, so notice these orange, these pinkish color ports, those are the default ones, and then you can add as many additional ports you want, set them as input or output. Okay. Now, when data comes in on these ports, as I mentioned earlier, I'm just going to make this nice and small here so you can see it. They come in, they all sit in this one queue in the order of arrival. As again, going back, the initialization function happens before any data starts moving across the wires in any of the model. The first thing is the label :begin. So when the code here comes in, or when it starts filling up the queue, first item of the queue comes out.
Deepak? Sorry to interject.
This conference will now be recorded.
So today we're going to cover the script block and the DRAM block. The thing is, we're going to start off with an explanation of how the script block works and relative to the expression list block, which you saw in session 2. We're also going to look at all the different features and functionality of the script block and and some examples of how they're used within VisualSim. So to get going, I'm just going to have a block diagram of the way the script block is set up. As you can see, it has an input queue, has some pre-initialize, which is equivalent to .h file. This is where when something comes in, this is the line where the code actually starts executing. Anything above it is executed only once and at initialization time. And then there are a few features, like these are keywords, and there's methods and functionality and things like that. We'll go into that a little more detail. Now, taking a look at an actual block diagram, the block that you drag and drop, it's located in the behavior library. The block that you drag and drop, it shows up like this. The first thing you need to have is you need to have a unique name. Every script block in the entire model must have a unique name. So if you're putting it into classes, it makes sense to create some sort of a name for that class, so that way you could use it in different situations or scenarios without having to actually go in and edit each component. Now, there is something called a block reference over here. If you do path, which is this one over here, if you do path plus block reference, then it automatically concatenates the hierarchical path from the top level of the model down to the block and adds the block name to it. So it automatically creates that a unique name for that particular block. So it's right over here. You can say path, which is this one over here, path plus block name, and it'll automatically create that. Now, the block itself, you can have any number of input and output ports. So if I go customize ports, you can, the first two are the standard ports that come by default. That's the kind of the pinkish, orangish color that you see there. And then you can add as many input and output ports as you want, set them as inputs or outputs. That's the first thing. The second thing you can do is, if you double click on the block, the code actually pops up. Of course, you can put any sort of comments with the comment setup right over here. In this case, there isn't a label :begin, but it would really be something that would be at this level over here, something like this. Okay? So this indicates that this is the start of the code sequence. As you notice, there are some basic difference between this and C programming. One thing is the semicolons at the ends are completely optional. That's one. The second thing is there are some very specific methods that are really good for performance modeling, and those are all should be available here for use. Another thing that you have is notice there's no other files that it references, no pointers, no classes, because those are actually part of the compiler. The compiler would pre-compile all of those and store them as a native file. So you as a user don't have to do any of that kind of stuff. Now, the other thing about the block that's very critical is that it always goes from this label colon begin and its sequence is down, unless it gets something like a send to label where it gets sent somewhere else, or it sends an output to some other block, or just to the output port, or directly from this block to another block. I'll explain all of those a little bit, but it's enough suffice to say that it's always sequential unless it goes into one of these other things by doing a jump. Now, there are two types of the script block. One is called a script and the other is called a smart controller. The smart controller is really the block that's used along with the queue block, so it's specific for where you want to create arbitration or things like that. Now, comparing with the expression list and this block, there are three main differences. The first difference is that it's an ANDing of the ports in the expression list. Only if inputs arrive on all the ports will the block fire. If it is ORing, then it's, the script block is an ORing of the ports, which means the arrival of data on the ports are simply just for convenience to say where it came from, but it's all stored in a single queue. Now, the port name is stored along with that particular transaction or data structure. Now, another big difference is transitional ifs are the only kind of coding structures that are available with the expression list block. That's like x is greater than y, question mark, 1:0, that kind of a format. That's really the only one that you have in the expression list. Here, we actually have all the standard constructs of C programming. The first one, as I mentioned, is when the code starts executing, which is when it gets data on the input port, it starts from the line that says label colon begin. There's some debugging capabilities. We'll look at that in a little bit. We also have a new tracer functionality that's available that allows you to specify multiple script blocks in the model and specify what time to what time. So it'll actually capture in a single file, it'll capture the activity or the sequence of code execution. So you can actually see that the code executed in block 1 or script 1, then executed script 2, then executed script 3, then went to script 2. So you can easily debug code across multiple blocks. Allows you to do that. And of course, as I mentioned, you can transmit from within the code you're using the send function. You can send it to a local or a global connection or to other script blocks directly. So you don't need a wire or anything like that. Every other one of the functionalities I mentioned today, we do have the examples in this directory. Now, really the differences between the script and the smart controller is very minimal. The one thing is the smart controller block has an extra port called the pop port. The purpose is for this to connect to the queue block. That's really the only difference between these blocks. This one here has the additional functionality for plotting, and I think that's about the only difference right now. So if you don't really want to use multiple blocks, you can just go with the script block and add your own extra port to the block for doing the popping. These are some of the standard, these are the keywords, the reserved words, and the methods. I'm going to walk through each one of these so you understand how they're used, so you don't really have to memorize them right now, or have to explain them right now. Okay. Now, the script itself, when you right-click on it to configure, there's two sets. The one that's mandatory is the block name. Everything else is optional. Now, some of these things, if you want to restrict, are available to you, but things like the max queue length, when you define queues inside the block, this one becomes a parameter. Now, it's no longer required because the queue will automatically resize. So it's an infinite size queue, so you don't have to worry about it at all. Now, we're going to go over some of the methods to get started with. The first one is the list of methods. One is the, oops, everything's really timed. So the first one is a go-to method where you can go to a label or you can go to another address point from anywhere in the code, or you can just say go to exit, which is just that it ends the code right there. Apart from that, there are these functions like a wait. A wait is a blocking structure, which means that once you put in a wait, it will lock it out for that period of time or wait for an event, things like that. And I'll explain about events in a little bit. Send is what we talked about, where you can send it to a port or to a label or to another script block. The queue and the time queue, this is a standard queue, so it has all the standard functions of putting it in the queue, popping in the queue. You get statistics. You can do a take, which is just removing it without popping it out. The other one is a time queue, which is kind of associated with the wait, which is a non-blocking thing. So what happens is when something goes into the time queue, other parts of the code can continue to execute. The wait means the entire code is locked out. This is to send something for plotting. You can send it out to an output port or to a virtual destination. So it allows you to do that. Now, we'll first look at the goto, and as I mentioned, it's an address or it's a label. Now, the label is the next thing that you can look at. Labels are just convenience to define a particular address. Label : begin is the only one that's kind of unique. Everything else, you can have whatever name you want. Now, one of the key things is labels cannot be variables. They can be parameters, though. Wait function. My friend, wait function can be a time, or it can be an event. An event is something where somebody else can generate an event using this function called event, can trigger it from anywhere in the model, and once this block gets the event will start, will remove this from the wait condition and start executing the next line of code. Events are always global, which means if there's an event in one part of generated in one part of the model, it's available to everything in the model. That's an important thing, that events are always global. The second thing is with the time, if it is an integer long, then it aligns to clock boundaries. So the integer value, say it says 192, that becomes 192 megahertz. If it's 1.0, then it becomes a delay. So if you want to align to clock boundary, use the integer long. If you want to just have a delay, just do a double value. The next one is the send function. This does two purposes. One is it sends it to other places within the block or on a port or some other block. But in addition to that, when it says this send to a label, this creates a separate thread. What that means is you can actually have multiple individual threads within a single script that all kind of run independently, and they can all run concurrently. But at any one time, only one thread runs. So what happens is, as it goes through a single thread, when it encounters a time queue, that's when it looks at all the other threads and sees if anyone else is waiting to execute, and then it goes and starts executing. So that's kind of how we handle the concurrency between them. The next one we have is the queue function. The queue function is essentially the ability for you to create a queue in the block, and it takes 4 parameters. The first is the name of the queue, and what is the data structure you want to take. Now, at this point, I want to stop a little and talk about a concept called port token. The currently executing data structure, the one that's currently in the line of code which is executing, the data structure that is called port token, the one that's currently executing. So rather than using the name input, which would, like we use in the expression list block, if you use port token, then you don't have to worry about figuring out what is currently executing, but rather okay, it executed the previous line, going to come in to the next line. That is the data structure that's going through. So rather than using the port name of any port, you can just use the word port token, and it'll take care of being the currently executed. Another thing is also you can put something into a time queue, and then the next data structure can come in on a port, and it can start executing. At that point, the second data structure is the port token. When when the data structure comes out of the time queue, the first one, that becomes a port token as it starts executing. So it's the one that's currently active is called a port token. That's a kind of a very important distinction, and that's one of the reasons why the script language kind of simplifies things a lot, because you don't have to worry about what's currently executing, is it doing correctly, but rather the block takes care of it. The queue function has a lot of functionality in it, like the length, stats, get, pop, copy, put. The couple of things: the copy, pop and copy. I'm sorry, get, pop, and copy doesn't need anything on the left-hand side. Length and stats does require something on the left-hand side. So get, pop, and copy will write it to port token. So next line, if you use port token, whatever was the data structure that was extracted from it is the one that will become the port token. The length and stats, you need to assign it on the left-hand side to a data structure and to a variable or to a field of the data structure, and then that will continue down through the flow. Now, if I use this is the kind of the short notation, and this is a full notation. If I use the full notation, all of these parameters here could be actually using a field of the data structure. So you can say port token dot name, port token dot token, port token dot priority. So it could actually get the information from the currently executing port token and start using them. Now, regex cannot be used for any one of these. Similar to the time queue, and as we remember, we had the server versus the queue block. The time queue, the equivalent of a server block. It's a non-blocking wait. And again, it has the 4 parameters. The only difference is we now have the time queue where we have the name, token, priority, and delay, which is the name of the time queue. Port token is kind of the default of whatever came in, and whatever you can set up a priority for each one of these. Now, of course, all of these can be fields of data structure, and that's the time of delay, the delay that it goes through. Again, if you have it as integer or long, it aligns to clock boundary. If you have a delay, it's just a double value. Plot is a nice thing, but it's not really used that much, so we'll kind of ignore it. We're also trying to move to GNU plot, so it's really not that important. Okay, the first one we have is the if-else condition. So it's standard if, else if, and else. So you can have any piece of code. The only rule that we have is that there should be at least one line of code within each one of these. So you can't have an empty item here. It'll throw up an exception. Now, another one that you can see over here is the port name. So remember, you can have multiple input ports. The port token coming in on any one of those ports gets an associated information called port name. So, and notice there's no port token dot port name, it's just port name. So whatever is the currently executing port token, associated with that is an item called port name, and that will tell you which port it came on. So this kind of becomes useful when you're like trying to look at, okay, data is coming in from 3 different flows in my system. So I want to, if it's coming from flow 1, I want to do this. If it's coming on flow 2, I want to do something different. So it allows you to do that.
This conference will now be recorded.
So now that we've seen the if statement, the next one we're going to look at is the while loop. So the while loop is something where you just want to have either an infinite loop or till a deadline has been reached. Now this obviously is different from the for loop. Now you can have multiple while loops within a hierarchy. You can also have if-else statements within them. You can have a send within them. All of those functionality is available to you. So there isn't any restriction on how many levels of whiles you can have and things like that. So it gives you that ability. Okay, the next one is the for condition. So we do have the for loop. Now, there's a couple of things that's different from C programming for the for loop. By the way, this is a new feature in version 19, actually in version 18.4. And what you see over here, which is different from C++, is that you have a starting and ending, and that you always need the three variables. You can't jump with just one variable or two of them like it's C. Starting, ending, and then you notice here I have to say IDX equal to and whatever the function. So it's kind of like an expression that you're putting right over here. And again, the code can be anything. You can add whiles, you can add if else's, you can add any of those kind of things. So those are all available. But remember, for for loop, you do need three of them, and the third one is an expression. Now, the next one is a switch case. And it's again also a little bit different from C programming. Now, there has been some changes done over here where we support the exact format, but you can switch on, say, a port name. So when a port token comes in, you can see what the port name is, and then it can send it to one of them, or it can be a field of the data structure, or it can even be a variable. So based on a variable value, you can send it to any one of those. Key thing here is that all of these are capitals. They're all caps. That's one. The second one is the last one must always be default. And of course, you want to terminate these, you can just use a go to end, or you can just let it flow through. But if you use go to end, it'll just jump out and it'll come out of the this thing, come out of the loop itself. Now the default, I'm sorry, go to end means it'll just terminate, which it comes out of the entire code itself. So it'll wait for the next data structure or port token to come in and then start at label : begin. Now, default is the very last one. So if none of these match, it has to send it there. There always needs to be, the last one always needs to be default. It's a requirement. Now, there's also a subroutine capability. So you can do a call, and you can call a subroutine, which is again a label. And once it's executed, it returns. Now, one of the key things here is that it should always be a port token or should be a data structure for this to work. So when it sends it over here, it cannot be an integer or just a singular data type. It needs to be a complete data structure that is sent from here, from a call to a label, and then on the return back also. So when this happens, this stops the flow, sends it over here to execute, and when it's done, it sends it back here, and then it continues down the flow. Now, when I look at the variables, so when something comes in, I can have port token dot field, and then you can have a variable, which can be a variable that's inside. If you recall from the previous session, we had block, local, and global. It can handle all of those. And of course, you can concatenate or add with the other fields of data structure as well. Couple of things. If you want to handle this, you can do this as read field is a regex function. There's also something called check field. So check field is something where if you're creating your own code and you want to make sure the user has added that field to the data structure, you can always use the function check field and then put the data structure, a field name, to make sure it's available. Read field is something that where the field can be read right here. You can also do a read memory and write memory. So that's also available to you, especially to a variable. Now we come to the port token, which we were talking about. So if the port name is virtual, it means it's coming from a virtual connection, like either from an out block or from another script block and things like that. If it's got an actual name, then it uses whatever the input ports on these blocks here. Again, in this case, the port token, you notice it's being sent out here. Well, in this case, the port token is sent out over here. So that's the use of that's how you can potentially use a port token. Now, you can use a port token in the script as just a sequence in the sequence of execution as well. Now, going back to the wait, as I mentioned, is a blocking. If say two transactions come in, and the first one comes in on input and it has a wait, even though there's another one on the input queue, that cannot execute until this wait has been cleared. So it's cleared and comes over here, and then it comes out. Then it'll take the input 2 and then execute, come over here, finish this, and it comes out. So if a wait essentially blocks out everything, if there's additional labels, like additional threads running, even they get blocked out of this thing if you use a wait. Now, opposite of wait is a time queue, which is a non-blocking switch. What this means is that, say, for example, in this case, input comes in, I send it here, I put it in this time queue and waits for 1 second. Before it comes over here or before the time queue is cleared, say input 2 has arrived, immediately it starts executing, it jumps over here, does this, puts it into the time queue here, and if this one comes out earlier, this will start send it over to the next line, which in this case is an out. And then later on, when this one completes and it sends it over here, it'll send it out. So in this particular case, other things can continue to run if the if you go through a time queue, because it's a non-blocking wait. So here's how you can use a queue. Just goes into just using it in the line. You can do a put or you can just put a delay. I'm sorry, a delay value for the time queue, or you can use a pop. So it's right there. So put and pop will put it into the port. So when it puts it into the thing, put and goes to next line, the port token is still currently executing. Similarly, when it gets a pop, the pop writes it into the port token before sending it to the next line. Time queue is kind of the same way here. Now this implements the very first tutorial, the getting started tutorial in VisualSim, which is, you write it into a queue, you send the first transaction out, there's a delay, and then it comes back and pops the next item. You're kind of doing the same thing here, but within these lines of code over here. So that's an important thing to understand, is that this can replace a bunch of blocks in the model as well. So when you're trying to consolidate a lot of them, or you're trying to speed it up or things like that, the script is a good way to do that. I'm not going to do the plotting. I'm going to skip that. The other thing we can look at is the virtual connection. So when you do a send, as I said, you can send it to an output port, or you can send to this one to another to an in block. You can just use this and send it to an in block or to another script. So that's an important consideration. Anytime you see SC, this means smart controller. So again, this is where I can send to another block, and notice here the port name is virtual. That's where it's going to show up. So when I send it over here, it comes to the head of the queue because virtual has higher priority. And then when it starts executing, it'll identify it with this, and it'll start executing the code. Okay. Another thing you can do is we have a schedule task regex function, which will allow this line to send it over to a system resource or a system resource extend block, and then when it's done, it'll send it back there, and then it'll continue down to the next line. Important thing. This does hold on to it, kind of like the time queue, hold on to it before it sends it to the next one. Now, obviously, you can have scheduled tasks in multiple scripts, and that works completely in conjunction with the mapper block when they're sending it over to the system resource extent.
This conference will now be recorded.
So one of the key things that you can use, of course, you could use that short notation, which is queue or time queue, the name, comma, length, or stats. But what you can also do is use the more traditional get block status method. You can have the block name, so that will be your script name, and then the string name, which is the whatever the queue name is, and then the whatever the, I'm sorry. If you're inside of the script code, I was thinking about outside the script code. If you're inside the script code, you can get the block name is whatever the name of the queue is. The name is where it's a length, copy, take, stats, get, things like that. And the last one is the index of the queue. It's always one based index. There's not a whole lot you can modify for anything that's within the script. Remember, if you're using a queue or the server block, you can have multiple indices for that one. But for this one, the last one is always one. Now, the other one that you can do is within the code, you can get this queue name, which is the block name over here, underscore length, and that'll automatically give you the length of the queue. So this is kind of a variable that's available within the block that you can just read from it. So you can just use this, say, within an expression or assign it to a variable. You can do all of those. So that will be in lieu of using this get block status to get the length of the queue. So just kind of an easy way where we store the length of the queue. Now, in terms of the queue itself, there are certain attributes, the max queue length and number of queues. Now, if you remember the queue block, it's got the max queue length, the number of queues, the initial queue thing, which is either first token flow through or first token enqueued, reject mechanism, which is incoming tokens rejected, or the lowest priority, and where it's a FIFO or LIFO, that's your queue. Here, you can, the max queue length and number of queues are no longer a requirement because we automatically resize these queues. As a user, you don't have to worry about what is the maximum number of queues or what's the queue length. It'll just keep on increasing the size of the queue as you keep putting more stuff in it. Of course, the statistics will tell you, what is the length and how much delay, how much time it's spent in the queue and all of those kind of things. So the queue block is just a standard library block. So if I go into the thing over here, I could just bring one of these queue blocks over here. So I have data structure coming in. I define all these attributes, and then I have a data structure going out. So it's kind of an easy block. Now, similar thing over here is in the script block. I can, define the queue here. Say I can put it over here, and later on, after a period of time or based on some input activity come in, I can do a pop here. So in this particular case, what it's doing is when it comes in on the input port, I put it into the queue and I do a put. If it comes in on a pop port, which is the second one over here, I then do a pop of that queue and then send it on the output port. Now, in this particular case, I've got a third one, which is stats input. If it comes on the stats input, I generate the stats, and that's the port token value I send out on the stats output port. So I can do that. Now, notice here there's a key attributes. I don't have a left-hand side for this one here. So this one automatically gets written into port token. So when it comes over here, it actually puts the port token is got the stats of this queue, and that's what it's sending out. So this is a very important consideration, is that here it's not the thing that came in on this port on this input port, but rather if you assign it like this without a left-hand side, then the port token becomes the result of this particular expression. It's a very important consideration here. Okay. Now, there are a lot of uses, as I mentioned, for the script block. Obviously, managing queues and doing processing on queues is one. The second one is just generating traffic generators. So this is where, if I want to create a very complex traffic generator that has like an address, and then I've got an event. So I send it out to the AXI bus, and then the AXI bus sends me an event before I can send the next one. When I have those kind of things to do, then I can put that into my script for this traffic generator, and it can wait on that. In this case, we've got to wait here for time. It can be wait on an event. So when that event comes in, it can continue executing. So you can use this for generating very complex traffic profiles and things like that. Now, this one here is just a simple thing to show you that this one here shows that, yep, it's got the field here. Now, there's a better one right now that's available, regex function, which is check fields. And you can put a whole bunch of fields here, not just one, and check if all of those fields are there. So typically when we have label : begin, right after that, we do a check fields to make sure all the fields we need for processing is listed. And if it is there, then we say, okay, we're going to continue through the executing. Otherwise, we can throw out an error to say, hey, some fields are missing. Like for example, right over here, we could throw my exception, which is no field name, my field is available. So throw my exception essentially terminates the simulation and brings up an exception window which explains what the error is. Now, one of the biggest regex functions that we use is the array processing. There's about 40 or 50 different regex functions related to arrays. And so you can use any of the array processing functions within the code, within the regex, within the script code here. Now, going back to the earlier question about the statistics, the input queue. So you can have a stats ds, get block status, block name, which is the this particular script, input underscore queue stats. So you can use this to get the statistics for this particular for the input queue. And if you notice over here, I'm sending it out on the stats output queue, on stats output port, whatever the stat data structure value was. It's not sending out port token, but rather sending out this value right over here. This one here is just a standard when you use the stats thing. This is the one that is kind of generated out of it. This is the standard data structure. Now, queues don't have a utilization, but servers, system resources, channels, all of those kind of blocks, or even the time queue within the code, they would have an utilization. So the utilization is a measure of how much time over the period of the simulation that the particular queue, or the time queue or the server or system resource has been busy. Now, the next question comes up with the debugging. There's a couple of things for debugging. One of them is, of course, you can send messages to the command line. You can set up, you saw that expression, throw an exception. You can write statistic. You can have like a debug port and you can write data out. So a lot of blocks, standard blocks in a library, you'll notice that it has these debug ports, and in the debug ports, you'll get a lot of information. So those are things that you can just use send to debug port and a particular string, or a string plus some variable values, a string plus some data structure values. All of those can be sent out. Another way to look at it is a process called listen to block. So now I'm going to go over to this one over here. I'm going to do a listen to block on this one. Run it. Hoping it gives me an error. If it doesn't, I was unlucky. I thought I was going to get an error. Made some changes to the block. But the first thing is right up here, it tells me all the parameters of the particular block. So you can see all of those details. The second thing that it does is it gives me, here was the original script. This is how the script was written. Any spaces, any empty lines and things that we listed here. Then it shows me how internally how we store this particular script, and you can see what's the address line and the original line. So you can see what the difference is. And at this point, it's compiled it. So you can see how long it took to compile, in this case, 263 milliseconds. And right here, in this case, it's it's directly starting up. So the thing came up here and it just started. So the input came in. This was the data structure came in, and then it did a sequence of execution. So you can see this was the expression and this was the result. You can see that. Then you can see at some point it sent it out to the plot port. Just going to go a little bit further. You can also see if you get an if then else or a while expression or something, it will show you in the next line whether it evaluated to a true or false. So that's another one. As you see, it says go to 4, and you can see what happens to that particular expression. So it goes over there, and then it says end thread, which says no result, which means it's over. There's nothing more to do there. So as you can see, the sequence keeps generating. Now, here's an important thing. As part of this thing, you notice that it's going to this thread over here. So terminated the thread. And then you can see there's a new thread that starts executing. So if you're trying to evaluate that I've got 4 different threads in this code, and I want to see what happens to the threads, you'll actually see when it sends it over to a label, it'll show you that's the starting point of the label, and then it'll start executing from that point. So you can track to see if your independent threads or your independent subroutines are executing correctly. So this is an important way to be able to track what is going on in the particular code. Okay.
This conference will now be recorded.
So now that you've seen the script block, the next topic that I'd like to discuss is the RAM block. The RAM block is a standard library component in VisualSim, and it's something which we have been able to use and can be used not just as a DRAM, but it can be used as an SRAM, it can be used as an NVRAM, it can also be used as a flash. So it provides you the kind of the framework and infrastructure to create it to whatever type of memory that you want. Now, realize there are some caveats to this one relative to our cycle accurate memory. Couple of caveats. One is that this block doesn't handle any addresses. The addresses are really ignored. The second thing is it doesn't break down the signals into its individual activate, like a RAS, RP, RCD, and things like that, but rather it expects that you calculate it outside and then bring it in and provide it as part of this block. So some of the important functionality is when the data structure comes in, it first executes this controller time. It first puts it into this buffer, and if nothing is active within the memory, it will start executing the controller time. So now the controller time is a complete regex expression, and you can actually have a field of the data structure or a variable that comes in that actually tells you what is the delay for that particular request coming in terms of controller. So controller time is kind of your activate time or your WTRs or DQSS and those kind of functionality. Now we do have a table in the tool that will tell you for a DDR4 for going from a read to read or read to write or write to read. This is kind of the delay for the for your activate or your controller time. So you could use those values directly. That's one thing. The second thing is you can define the refresh rate, which is how many cycles. So in this case, it's 250 megahertz. So it's about every 4 microseconds is when it's going to trigger a refresh, and it takes 32 cycles for triggering the refresh. If you want separate banks, in this case, it just runs, the whole thing is considered one bank. If you want separate banks, you can instantiate multiple of those, and then each one of them works as a separate bank. So you can do something like that. In this case, the whole thing is treated as one big bank of memory. That's one thing. The second thing is the access time. So the controller time is your activate time. The access time here, the actual delay to go get it from a memory cell. You can have any type here. The key thing is the reads and writes. So when a data structure comes in, it first recognizes it a read write. A prefetch is a type of a special type of read. It checks one of those, and then if it's one of those, then it will do that particular operation. A read is where it gets the data and then returns back as a write coming in. if there's a field called a task flag set to true, it will send it back as a read. It does that. But for every width of the data of the request, so if it's say it's 32 bytes, that's a request coming in, and the width is 4. It's 8 individual requests that we're handling. Oops. So I think I made a mistake here, so I'm just going to go back a few things. This is the RAM block. We got it out of the memory. That the RAM block has 2 sets of input and output ports. They both are identical ports. This is not a dual ported RAM. It's just for convenience of if you're connecting it from the left side or right side. So it still has only a single input queue and a single controller. It's not separate. Some of the key parameters, settings that you can have is the width, and the second thing is what type is it. LPDDR and a DDR in this particular case are treated as the same. So a DDR3 or a DDR4, and LPDDR3 and LPDDR4 kind of match 1-to-1. When it comes into the in the port, it gets stored in the FIFO. So you have a length for the FIFO. And of course, you can do a get device status is a regex function to see if this FIFO is full or empty. I'm sorry, empty or has some data. So you can use that for before deciding if you want to send something over to the memory or not. Now, the entire RAM block is treated as a single bank. It's not treated as individual banks. So if you want to model something like 8 banks, you can instantiate 8 of those, or use a dynamic instantiation for that as well. The delays, there are 2 parts to delay. The first is the controller time, and the second is the access time. The controller time is all your activate signals, so the RAS, RCDR, Ps, WTR, DQSS, any of those kind of things. So those could be a delay that you would calculate in front of it based on attributes like, you can set up an address, you can set up what my source is, what's a command based on that, say, is it a sequential, is it a random, is it a write to read, is it a read to write, all of those kind of things, and based on that calculate a value and then feed that here. Cycle time is whatever the speed here is, that it's 1 over that speed, is that here. Here you can have a complete expression, so it can be a field of the data structure, it can be variable, it can be any other element right over here. So once it comes out of the queue, it goes to the controller time, and then this one here is on a per width basis. So if I have 32 bytes, which is 8 counts, 8 ticks or 8 counts, it's 8 times 5. This is in nanoseconds, so it's 8 times 5 nanoseconds, so it'll be 40 nanoseconds. That'll be the time to take it out of the memory and then send it back on the output port. So that's a key thing. Now, a second attribute is that I can turn off refresh. In this case, the refresh rate cycles, again, based on the speed here. So in this particular case, it's 4 microseconds for refresh, and it'll take 32 cycles to complete the refresh. Again, there's nothing separate as a bank because the whole thing is considered a single bank over here. Now, there's a field called a_task_flag. If it comes in as true, the write response is sent back as a read data structure. That way, there's only a 1 cycle delay across the bus and everything. If it doesn't have a task flag set to true, once the write is finished, it'll come out on this lower port over here. That's the output 3. Now, what can be modeled with this? Pretty much anything can be modeled. You can connect this to a bus. For example, I can show you a design here where we've added some logic right in the front here. So notice the flash here. So it actually looks as a flash controller we have defined. Depending on certain attributes over here, like your commands, where it's a read or write and things like that, it sets different values for your controller time. So control time here is set with whatever the computed values are over there. And then when it comes into the flash block, it uses that field time for that activate delay. So it comes out of the queue, it does this delay, and then it sends it out. Now notice here also, the width has been set to 1 and has been set to str. The reason, and then the refresh, so we added a new parameter. Notice here, in the earlier model, we did not have, I'm sorry, the default one, if you look at it, if you look at the default one, it doesn't have a field called refresh, but you could add a field called refresh, set it to false, and what that does is it turns off the refresh function. So things like SRAMs, and in this case, the flash doesn't have refresh, so it's turned off. So same block can be reused for a variety of purposes. It can be used as a flash, so a NAND can be used as a RAM, can be used as SRAM, DRAM, any of the other types of RAMs as well. So it becomes a very powerful block, especially when you're defining it at the system level. Another thing about this DRAM block, which is kind of critical, is that there are no addresses. So it's not going to go and find a particular address. Your controller time latency coming in is what determines whether it's random or sequential and has the delay associated with it.